This is the third lecture on linked lists, and in particular, adding nodes to a linked list where we have only a head node. At this point, I'm assuming you've already been through the earlier ones, and so you're familiar with how we got to this particular memory map. What I want to do now is take a look at what happens when you want to try and print or display all of the items that are in the list. We have currently 5 of them: Wilson, Smith, Miller, Jones, Adams, and we want to print those out. Let's take a look at the Java code. I'm going to come back to the Java environment. Execution has already gotten to the point where that list has been built. I'm currently sitting at this line of code, and I want to print. Just to confirm that we are as we organized it, or described the organization, I'll take a look at list. Head points at item 31. Item 31 has Wilson. Next one, Smith. Next one, Miller. Next one, Jones. Next one, Adams. And the next one, null, indicating we're at the end of the list. So we want to be able to display Wilson, Smith, Miller, Jones, Adams to the screen. Of course, this is the output from the preceding call to print before we had added that last one, Wilson. And again, remember, adding means adding to the head. Well, let's begin program execution into the print. When I step in, you'll see I arrive at print. Is it empty? No, it's not empty. So we continue on. It's going to display the label list contains. Fine, list contains appears on the screen. Now, the process of walking through a linked list, and this is very common code, so it's something you need to get used to. We're going to start at the head. We're going to continue doing things so long as the value in current, which initially captures what's in head. Now, head at the moment, what does it have? Head has, if I open up this, head has the value 31. So essentially, this line of code here is assigning the integer value 31 from head to current. At some point, I'm expecting that current will be equal to null, but not yet because we're starting out at the beginning of the list, and 31 points at or refers to the first node that contains Wilson. All right, so I'll begin program execution at this line of code. Is current null? No. Current has the value 31, and when we continue execution, we're going to output the value in our data for current. So when I take a look at current, current has 31, and that means Wilson will be displayed to the screen, and indeed it is. Now this is a very interesting line of code, and it's one that you will see commonly when dealing with linked lists. It's kind of like I++ is a tool used to increment to the next item, perhaps in an array. Well, this is the tool that's used to, in a sense, increment to the next node in a list. So current is currently 31. That's its identifier value. That's the location information of an object that contains Wilson and also contains next, which is the number 25. So essentially what I'm asking here is assign the integer value 25 right back into here. And when I allow that to execute, it does. Because when I take a look at current, now it has the value 25. Effectively, I have walked to the next item in the list. Remember, I started with Wilson. Wilson was in a node located at 31, and then the next one, Smith, is located in a node at 25. Is current equal to null? No, current is equal to 25. So we continue. Display the data that's stored in current. And of course, data is 30. And it outputs Smith. There it is. And a little bit like I++, this is going to move me to the next item in the list. Current is currently 25, but you can see that next is 24. So I'll be assigning the value 24 into there. And when I take a look at current, yep, current has 24. Looking at Miller. Outputs Miller. Moves to the next. Current is 24. It's going to take the value 23 and assign 23 right back in there. And when I take a look at current, yes, it has the value 23, giving me access to Jones, so that when I output the data here, yes, I'm outputting Jones. And there it is on the screen. Current has been moved to the next one, 21, Adams. Output the value Adams. There it is. Now this is important. Take a look. Current currently has the value 21. I'm going to access next, which has the value null, and I'm going to assign that back into current. What's the value of current? Null. Oh, great. I'm done. I drop out of the loop, and I no longer have need of current. Now, it was very important that I make this temporary variable current, because if I had made the mistake of doing RLN head here and here, I would have corrupted the linked list. Head has to remain, in a sense, anchored the way it is, and current was a temporary little variable that allowed me to walk through.